My presentation is about transforming your data management with a NATS Jetstream exactly. And let's dive into that. Yeah, I will talk about the NATS itself, the NATS core, the NATS Jetstream, what's that tool actually offered to us. I will show the use cases where the NATS is actually good for. Then we talk about the components, the history. By the way, it's a really tricky slide. Then we will dive into the Jetstreams because it's actually related to the data streaming, data processing, and all that stuff. We talk about the streams, the consumers, the producers, and the most interesting part, I would say, is how to scale with the leaf nodes clusters. And yeah, at the real end, there would be the real world example with the, oh my God, in post. Yeah, in post, something tricky. By the way, how many of yours have ever heard about the NATS? No one. Nice. Okay, I will try to convince you to use, but okay, we'll see. Yeah, first of all, yeah, by the way, I will try to keep it really each side short because I have too much of them and I have 35 minutes, I think. That is the thesis that I saw or even heard on some of the presentation from the CEO of the NATS. And when I started to use it in production and yeah, in my time, I realized that that sentences really make sense to me. And yeah, the massive opportunity for Synedi is to provide enabling technologies that can be adopted across the board in any vertical solution. The vertical is actually the crucial word of that sentence, and I will try to convince you why I think like that. Okay? Where the NATS really helps a lot, IO data ingestion. NATS provides the ability that you can deploy your NATS packages directly on your edge devices. That is really a nice thing that you don't need to specifically to communicate from your devices to your server, to your cluster or somewhere else. But the core functionality that your device can perform without interacting with the outside world, let's say like that. Yeah, NATS obviously can stream, has an ability to stream processing. Yeah, you can create a stream, you can have producers, consumers. There are really a number of features that NATS has if it comes to the streams. Yeah, I will show all of them, almost all of them. Yeah, data integration, what is really nice about the NATS is that the data format that you can store in the stream is the format agnostic. You can store whenever you want. Maybe the JSON, bytes, proto messages, yeah, it's up to you. Microservices communication, that part is not specifically for that presentation, because we will talk mostly about the data, not for the communication itself, but it's worth to know that NAT provides actually that feature to communicate between microservices. And event-driven architectures. Yes, obviously, those two are actually related, but not exactly, because you can use NATS also in monolithic architecture, as we are using in our project. You literally, your two backends can communicate between each other just using the NATS, and yeah, that's really nice feature. Okay, yeah, NATS components, super simple, simply words. Yeah, at the last slide also we'll describe all the components, but the main crucial ones is the server, client, and storage, obviously. Yeah, the server is responsible actually for managing that communication, routing, filtering, and all that stuff. It's your core. Even the NATS call that the server as a NATS core, let's say it like that. Clients, it's your producers that produce your messages. So also subscribers, yes, in somehow way they consume messages from the NATS server. And the storage. The storage is the component which we will dive into details in today's presentation. And yeah, you can use we already started diving into that. You can use the file-based storage and memory-based storage. Obviously, the file-based is slower than the memory-based storage, but it's pretty much obvious. Yeah, that is an interesting slide. Please do not blame me. Yeah, the history of NATS, the programming, all the time when I'm on the presentation and I see slides describing the history or describing the documentation, I really hate that. But I decided, if there is one strong reason why I decided to leave actually that slide, is to, of course I will not talk about that, but the NATS was not designed as a streaming data processing tool. It was designed exactly as a messaging system to communicate between services, and that's it. There was no such thing like Jetstreams. There was just a NATS core, then was developed the NATS stan, a cast streaming, and then it was merged at some point. It was 1 year ago, and I really think that is an exception in the world, because initially the tools that are not designed and trying to handle every edge cases, they are usually bad in everything. And this is not exactly that example. This is why I say it here. Okay, key features of the NATS Jetstream. Yeah, persistence and storage. Yeah, you can have, as I said, the durable messages and ephemeral messages. Durable you can store obviously on the system, that you need a persistence of your messages, and ephemeral messages, they just go and fire. Various delivery rules. I know that it's not every tool offers that solutions, that you have multiple options to choose which delivery options you wanna, and yeah, you have at least once delivery when you focus mostly that you deliver a lot of messages and you want to be sure that at least one of them is delivered, but it can produce duplicate messages in your streams. At most once delivery, it obviously will not produce duplicates, but you can lost messages. And exactly once delivery, it is most, I would say, resource consuming, because there NATS implements the technology that when you receive the message, you will automatically acknowledge them. And it will offer you, it will be slow comparing to the previous options, but it is the most, I would say, trustable option, because it will offer you the only once delivery and without duplicates. Horizontally scalable. Yeah, horizontally, I like that word. Why? Because the horizontal scalable in that way means that you can extend your architecture without touching actually the code, but just adding clusters, gateways, leaf nodes. Yeah, we will talk about all of those. And what is really nice is that you can do that with the zero downtime of your actually ecosystem. You can just extend it. You can specify the PID process of the NATS. And when the NATS see, oh, bro, you added a node, okay, I will refresh, and that's it. It will refresh simultaneously each node, and it will, yeah, that's really nice feature. Not sure that it rarely used, maybe, but okay. Yeah, stream replication. I'm pretty sure that each streaming tool offers that you can replicate your streams, but also what is nice with the NATS, that you can replicate the stream not inside your, not on your local host on your machine, but you can say that, okay, bro, I want to replicate my stream to another cluster. I want to replicate it to another geofence thingy. Yeah, you can replicate and place it whenever you want. Acknowledgement and retries. Yeah, obviously that's actually a super simple thing, that the NATS will retry to push the messages and acknowledge. There are a couple of more options. I will talk about it later on later slides. Message filtering. Yeah, message filtering, you can filter not only for the subject base, but also use the wildcards. But what is the most important, that you can use that filtering not only for the simple pub/sub request reply, but also with the streams. You can say that, okay, that stream is interesting in the subject's full dot, I don't know, something, and it filters out only for your subjects. Policies, yeah, that is really interesting thing. The retention and discard policy, I will talk about in the next slides. Mirroring mirroring is actually the sourcing also missing there, but you have actually option to replicate your stream, you have an option to mirror, and you have an option to source. Mirroring means that you literally copy the state of the stream to the next geo cluster and all this stuff. But sourcing means that you read from the external. Like, I want to read the info from Wrocław stream directly there. Key value store, similarly to the Redis, I would say, just a simple key value storage. But what is interesting, the object store, that feature is still on beta. Yeah, at least it was during my when I was preparing to that presentation. But it allows you to chunk your files and store the file more than 1 megabyte. Like, you can store 1 gig in your stream and don't worry about the connection and all the stuff, it will be chunked. I'm not entirely sure which protocol is used for chunking and all the stuff, but yeah, it's available here. Okay, yeah, PyData, this is why you will see the Python code here. On the left side, you have an example of how you possibly can create a stream. And on the right side, this is the really powerful tool. I really encourage you to use the NATS CLI. It allows you to do exactly this, all the things that you can do with the Python, any language what you want. By the way, NATS has a huge community. You have numerous libraries, like in each language is Python, Rust, Go. You have a lot of libraries, but you can use the NATS CLI, and if you are a team administrator, I'm not sure, DevOps, let's say DevOps, you can use just CLI, and once you configured everything, you can push your config to the cloud or wherever you want, just using the NATS CLI. That's a really nice thing. Yeah, on the left side, super simple, importing the NATS stream config. If you, as I already, by the way, it's by default, the NATS library is async, which is also nice. But I already know that no one of you used that. But if you take a look on the actual implementation, it's super strongly typed, like typing everywhere. You know exactly what each option means because it's really super documented, self-documented packages. I really love it. Yeah, we can go super quickly on those options that NATS offer us for the stream. Yeah, you have the stream name, obviously. You have the subjects that will contain that stream, and you can have multiple ones, not only one. So, how you want to store file or memory, how many replicas, retention policies. In the next slide, we will talk about that. Discard policy is the same. Stream messages limit, per subject message limit, total stream size, message TTL. It's actually also an interesting one. It's I know I made a note there. It's a time to live. That is really nice thing is that you can specify how many time the messages in your stream will live. For example, if you specify 1 minute and you have a full stream of messages that are exceeded of that limit, they will be removed automatically. Duplicate tracking time window. Some of the features I'm not sure that, I personally never use them in production, but NATS offered them. Duplicate tracking time window means that how many time should go after the, let's assume that you have message full, and in 1 second, the next message full arrived to the stream, and you can specify, okay, if from the previous full went 2 milliseconds, and there comes another one, then reject. That's crazy. Allows message roll-ups. Message roll-ups, can you imagine that you have a huge stream of data, and obviously it's costly to store it all the time and not clean up in any way. And I'm pretty sure there are some use cases when you can merge your messages by some criteria. For example, we have 1 billion of message. You can specify the criteria of how you want to merge them, and they will be merged in the same stream. And it will be done automatically. You don't need to provide it, just the configuration. And allow message deletion and allow purging subjects or entire stream. yeah, obviously, yeah, simple config. Retention policies, discard policies, acknowledgement, placement, source and mirroring. Basically, the retention policies is also an interesting one because they determine how messages live in the system. Basically, based on the size, for example, their time or number, or you want to keep messages until a consumer requests them, it's an interest one, or the queue. If one of the consumer from queue already consumed the message, another one will not consume it the second time, yeah, obviously. Discard policies, then if new messages arrive, and for example, your stream is already full of messages, you can say that, okay, the new messages, if my stream is full, then the new one, I will discard them. I will not just accept them. Or I will remove the old messages and say them bye. Acknowledgement, you have a couple of ways to acknowledge message. Yeah, I'm just looking into the time. A couple of acknowledgement systems. You can acknowledge manually in case of pool consumers. You can acknowledge automatically, and you can just have no acknowledgement at all. Placement. Yeah, that's really funny thing. Yeah, I never used it, but yeah, during the preparing of that presentation, I was really impressed of the whole list of the options that NATS offer, because the placement means that how the messages are distributed across the cluster for the performance and reliability. That means that, okay, that I have, okay, there is no options, okay, but you have optimal, random, and singleton. Singleton means, okay, I want to consumer bar to consume all the messages. I don't care about the load balancing and all that stuff. You can say that random, it will randomly pick your consumer, or you can say optimal, and then it will be load balanced. Yeah, just NATS has his own load balancer, and it will be load balanced. That's really crazy. Mirroring, it actually replicates a stream content to another stream, and the source. Yeah, by the way, the mirroring, I will show you in the use case how to use it. But the mirroring is usually used to backups and load balancing purpose. But the sourcing, actually we can source another stream from the cluster. For example, we can even create a stream which will contain the parts of another stream. That is really crazy thing that you can do. That, yeah, I will show it in a moment. Yeah, consumer creation, the same. Yeah, the slides are pretty much the same as possibly the stream, but it's also really super easy. You just import the config, you provide all the options, and on the right side you have the options that how you can actually configure your consumer. Yeah, you can provide the name, delivery target. Yeah, as I said, NATS supports two types of the consumers, like the push and pull. Delivery queue group. You can specify the queue group, you can have multiple consumers, and you can be sure, yeah, by the way, oh, nice. Yeah, that was not me. Very nice. Can I move it? Very nice. MacBook M2 Pro. Yeah. Okay, let's continue. Yeah, sorry for that. Yeah, that's really nice. MacBooks. Yeah, that's consumers. Yeah, delivery queue group. Basically specifying you can be sure that only one consumer consumed the message. Yeah, just to don't have the situation where you proceed the same message 2 times. The nice thing that all of those things are handled automatically. You don't need to do that on your own. Acknowledgement policy already talked. Replay policy. That is really crazy. Replay policy. Instant, I think, and the another one is the original. Instant means that you will proceed the messages as they come to the stream. But original means that you will proceed the messages with the inexact way how they come to the stream. How is that even possible? That you know, for sure it probably will be used only for the testing purpose. When you want to test actually how your ecosystem works, you can specify, okay, I want to consumers, I want to test how it actually works. And they will specify origin, and it will reproduce the same traffic to my stream, the same consumption. Yeah, that's really crazy. Okay. I think, yeah, there I listed the most crucial one. I will not go into details for each specific option. Yeah, as I say, durable or ephemeral consumers, yeah, you can have messages and the consumers with the same type. And with the consumers, it works slightly different, because if you have ephemeral consumer, they all the time created a new one, and they will read the stream. But durable, if you specify the queue group or something like that, then they are inside the one queue group, and they will not proceed the same message 2 times. Acknowledgement, replay, filtering subjects. Yeah, obviously, as stream you can filter, your consumer can filter by subject. Rate limiting, heartbeat interval, the interval how the consumer. Yeah, by the way, is it the same? Yes. Yeah, consumer can configure a heartbeat interval to receive regular heartbeats from the Jetstream server. Like saying, hey, bro, are you alive? Yes, I'm alive. Okay, bye. Enable flow control. Like, or there are more options. Yeah, I just see the time, and yeah, I need to speed up a bit. But yeah, just read the documentation. It's super clearly documented, all those options. Okay, yeah, the consumer creation. Oh, sorry, those already. Yes. Yep. Push consumer and the pull consumers. As I said, there are 2 types of them. What is the difference between push and pull consumer is that push consumers are actually server driven. They consume message as soon as they arrive to the stream, and the pull consumer are client driven. The client asks for the message from the stream. And yeah, push consumers are, as I said, from the server. Multiple delivery models, also already have been said, can be load balanced. Yeah, as I said, we can specify the queued groups, and yeah, suitable for all latency use cases. It's how we can configure the push consumer. Like, it's one-liner, and you can have a push consumer. You subscribe the specific topic. You have a handler where you print. I'm just printing the message, and that's it. If you want durable, like if the same consumer is in the same group will, if you add a new consumer to that group, then he will not proceed with the same message second time. Yeah, that's just that simple. Yeah, pull consumer, as I said, client driven, and the pull consumer explicitly requests the messages. NATS also offers the way that we can pull not only one by one messages, but we can pull it for like with the batches. And yeah, the configuration looks like that. I added a couple of more options just to illustrate that it's also super easy. You just import the config, the policies, and you just specify there. Yeah, and you're fetching the message, you're saying that, okay, I want to batch like the chunk of messages like 10, and that's it. Okay, yeah, simple illustration. NATS Jetstream, push consumer, pushing acknowledge, and pull consumer, just pulling the messages. Yeah, the producer is super simple. They pretty much look the same because yeah, there is only difference with the naming of the function. You have a consumer, stream, publish, but they pretty much the same. And yeah, in that way, line 15 exactly, you publish the messages. You specify the subject, the payload. That's it. Nothing really magic here. Okay. The question how to scale actually, that is the interesting part. As I said, NATS provides different ways to scale. And the first one is the leaf nodes. The leaf nodes is something that I can't say that is a proxy. I can't say it like that because leaf nodes also not just routing, but they can interact as a real NATS server. And the most interesting, at the real bottom, you see the chair with the NATS. It's enough of you to have. You should be connected to the internet. It's already enough to interact as a leaf node. And we have a clients. We have a leaf nodes that is in the middle, which obviously can have the stream buckets, consumers, producers, and we have a NATS servers. And if the client asks the leaf node for some message stream or something like that, and the leaf node doesn't have it, then leaf node will redirect our client to the NATS server. That's basically the simple idea of the leaf nodes. Yeah, the leaf nodes also can have his own authorization and the accounting system, but unfortunately we don't have that much time to talk about that. But yeah, the authorization system I will show a bit later. Yeah, leaf nodes simplify the system architecture, and they're really nice to edge devices. It's scalable and resource efficient. Yes, you can have separation of your concerns, saying that, okay, I have a leaf node NATS interaction stream thingy here, and it should be super fast, and the other guys will source or mirror from, just read from that leaf node. And the nice thing that they, by the way, it's they can be clustered as well, and not cat. That's okay. Data aggregation and analysis. Yeah, the same. You can aggregate the data from the leaf nodes. NATS clusters, it's very similar to the leaf nodes, but the difference is that NATS clusters is interconnected NATS servers. They not redirect anything else elsewhere, but it's just a servers that are interconnected and uses the GoSIP protocol, which says that, okay, if one of the server is down, the other ones are aware of that. And that is really nice thing that it's auto discovery. And it's auto load balanced, because if one of them goes down, they start use different algorithms, how to identify the leader and all that stuff. They use the raft algorithm, I think. Yes, yeah, it's auto balanced. Auto load balanced using the raft algorithm. Yeah, you can have cross cluster communication, but I think that's not saying that much if you're not super aware with the NATS. Then I will show it an example in a moment. Yeah, real world example of the end use case. I took an example with the InPost. I'm pretty sure that everyone knows what is the InPost. Do we have someone who works in InPost? No. Okay, very nice. Yeah, courier delivery tracking system. What we want to resolve with the NATS. Yeah, we want to improve the package visibility. We want to optimize inventory management system. We want to improve customer experience by providing updates like the statuses, location. Want to update the locker availability monitoring, the patch command. Predict analysis for capacity planning, like all the things that can be handled by NATS. I tried to list a couple of them. I'm pretty sure that much more. But how possibly the architecture could look like? Yeah? Let's assume that we have a parcel locker, we have a courier, and we have another client. They are actually our clients in our architecture. And we have a leaf nodes, which are connected. For example, leaf node can be a courier. Leaf node can be the parcel locker. We connect them to the leaf node. The leaf nodes connects to the NATS server cluster, and the cluster connects to another geo, for example, the main post office in the Warsaw. Yes, and the nice thing of that architecture, what I like to really so much, is that you can separate what each of those components is responsible for. And we can simply say that Supercluster is basically on the left side, our NATS supercluster. Yes, it generates prediction, it stores inventory state for particular city, it's data post processing. Yes, it's something that is not customer facing and it shouldn't be that much fast. We have NATS cluster, it's a per city, and yeah, the core service per city. It's receiving packages status updates, inventory events, location data from courier hubs and vehicles. And the leaf nodes, it should be super fast because we want to, I know, you take a package and you want to lock your locker parser because yeah, obviously you need to lock it. Yeah, you have a split of responsibilities between all of those NATS thingy. Of course, a part of the NATS, you have your, I don't know, API, you have your workers, you have your actually application code that do something, but you don't need, you get rid of that network latency to talk with the, with the Warsaw from Wrocław in order to lock your, to update the package status. Mirroring, the NATS leaf node, I'm a leaf node, I'm locker parser, I have 100 packages. It's important to me to know that the packages, the real state of the packages, because someone can come and want to send a package, and I want to have the immediate results and the NATS server, not necessarily the main server in Wrocław, should have those informations immediately. And we can say that we are mirroring. Even if something is outdated for the NATS server office, it's not super crucial, but for the NATS leaf node that is located exactly in that locker parser, it's super important. The same we can source, as I said, we can, the NATS supercluster in the Warsaw can source each of the NATS server in one stream by using the different subjects. That's really crazy thing that you can do, because you merge actually two streams inside to one actually in the main supercluster. Consumer topology. The nice thing is that let's assume that someone closed the how it's called, the locker, that someone want to send a package. He closed the door, and we need to inform NATS leaf node that the package is locked, that no one can use it and block. But all the consumers, probably it's not the case, it should not even happen, but all the workers in the leaf node are busy, and they say, I'm busy, sorry. Then we redirect to the NATS server, but NATS server doesn't know, for example, it's just a use case, it's probably not possible, but the NATS server says that, bro, I don't know what you want from me. I don't know how to proceed that request. And you redirect to the NATS supercluster in Warsaw. Yes, it's super slow, but still you will get the response. And it will respond that, okay, so hey, I'm processing, I know how to proceed, and I will respond to the client. Yes, it's a really long road, but still it's it's called panic something, that your request will be proceed anyway. Oh my god, that configuration looks crazy. In order to achieve that, I probably need to spend years. That is not a Kafka, and it's super easy. I really convince you to play with it. Maybe there it's not that easy because there are a lot of ports, but I tried to hide which one the important. That's the config itself. It's super simple. You just specify the port what you're listening. You specify the Jetstream with the domain. You specify the cluster. The cluster actually routes means that, okay, how many server inside I have in my location here. And the leaf nodes. You provide the port of the leaf nodes, and the leaf nodes automatically will connect. They, as I said, the NATS uses the GoC protocol, which which allows you to auto-discover all the leaf nodes, clusters, super clusters, not inside the same network. That is really nice, that you can specify everything and you can check if everything works. If some of the workers goes down, then you already see that inside your another worker. You have accounts. Yeah, as I said, we don't have time to talk about the accounts, but obviously you can use each type of the authentication models, like the token one, the JWT, TLS, and keys, decrypted, and all that stuff. It's all of that is available on the NATS library. And how we create the gateway. Yeah, I skipped, that part probably is the visible one because I skipped all the ports definition. But in gateway, you specifically say in the name of the gateway, you specify the address, and that basically that's super simple. You have everything in one config file. You don't have to split all of them. You can just even reuse them, but just changing the ports, and that is really, really crazy. Okay, summary. Very nice. I think I'm on time. The NATS client, the package, by the way, the package, what I was really impressed of the small size of that package is that NATS server binary for Linux is 6 megabytes, and the client NATS library is 1.5 megabytes. It's super simple, like it's a super light package, and it can be deployed anywhere, like everywhere where you have the Golang compiler. It can be even Raspberry Pi, VM, Kubernetes, Docker, whenever you want. And all of that features is inside one package. And by the way, we didn't talk about the NATS authentication, as I said, WebSockets, monitoring and logging at all. And the NATS CLI. The only Jetstream parts was touched, and the scale thingy. And that's it. Thank you very much.